BC square means A square. Look at this. Look at the figure. It's very clear, huh? And AC square is B square. B square, right? Then AB square is C square. 2 AB is C and AD is X, right? We can write in this way also. A square is equal to B square plus C square plus 2CX. Okay, we have to prove this. Now, move towards proof. We will prove by statement and reasons. Look, in right angle triangle, you can see right angle triangle. Measurement angle CDA is 90. It's very easy, right? Okay. CDA. Where CDA. Look at the screen. I will show you. CDA, this one. This is obtuse angle, right? CDA. This one, right? This is 90. CDA. Now, look at the screen. Now we can write in right angle triangle. We know that we use the Pythagoras theorem. Pythagoras theorem is the square of the hypotenuse is equal to the square of the sum of square of the two sides. The square of hypotenuse is here. AC is the hypotenuse, right? So this is hypotenuse. Square of the hypotenuse is equal to the square of other two sides, sum of square of other two sides. So other two sides are AD and CD. AD and CD, right? It's very. You can write B square instead of AC, AC square, and X square instead of AD square, and H square instead of CD square, right? So we will write like this also. This is equation 1. Now we will take another right angle triangle. Which one? I will show you with another color. Look at the screen. With which color? With green color, right? Okay. This one. CDB. CD. This is CDB. CDB. This is a right angle triangle. This whole thing. CDB. D. CDB. This whole thing, right? Now, hypotenuse is the side opposite to the 90 degree. The side opposite to the 90 degree is BC. This is hypotenuse, right? This is hypotenuse. So we will write hypotenuse square means BC square is equal to BD square and CD square. Look, it's very easy. BC square is equal to BD square plus CD square, right? This whole thing. So we can write A instead of BC, C plus X. Look, this is C, this is C, and this is X. The whole thing is C plus X, right? So we will write C plus X instead of BD and H instead of CD. This is H. Okay. Now, this is equation number 2. We will simplify A plus B whole square, A square plus 2AB plus B square and H square as it is. Okay, this is equation number 2. the, this is given, you can see the reason is very easy. Pythagoras given, Pythagoras, and BD is equal to C plus X, so we will write C plus X instead of. Okay. Now this is C plus X. Okay. Now these two equations you have, right? Equation number 1 and 2. By using these two equations, what we will get, a square is equal to c square plus, how? If you, this is a square, right? On the left side is a square. If you substitute b square, right? A square is equal to c square plus 2. Look, this is equal to b square. So you will write b square instead of this. Look, you will put here, because b square, x square plus h square is equal to b square. So we will substitute the value of h square plus x square, which is b square, and these two are as it is. Like, okay, now we have a square is equal to c square plus 2 cx plus b square. Look, what is this? It's very easy. Okay, now a square is equal to c square plus 2cx plus b square plus b square, right? So you have a square bc, so you will write bc square. C is actually ac, it's a square, and 2 is 2, and c is ab, and x is ad. So that is what you need to prove. You needed to prove this one. So we have proved the theorem number 1. It's very easy. First you take the right angle triangle of the smaller one, and then you take the right angle triangle, the larger one. You will write two equations by Pythagoras theorem, equation number 1 and 2. You substitute x square plus h square